Welcome all, I am Vishwas Khere from SSR College Silvassa. In today's tutorial, we will talk about functions of several variables, in particular level curves. We have seen two methods for visualizing functions in last lecture, arrow diagrams and graphs. A third method is contour lines or level curves. On contour map, the points of constant elevation are joined to form contour lines or level curves. Now let us see precise definition. The level curves of a function f of two variables are the curves with equation fxy is equal to k, where k is constant in the range of f. A level curve f x comma y is equal to k is the set of all points in the domain of f at which f takes a given value k. In other words, it shows where the graph of f has height k. The level curves fx comma y is equal to k are just the traces of the graph of f in the horizontal plane z is equal to k projected down to the xy plane. Here you can see this is a graph, is the portion of a graph of a function, and here these are the level curves. These are the curves which is obtained by taking its intersection with z is equal to k plane. For different heights we will get different lines, and when these lines are projected in xy plane we get the level curves. And here you can see it is written k is equal to 20, k is equal to 25, k is equal to 30. So for different values of k we will get different level curves. So if we draw the level curves of a function and lift them up to the indicated height and piece together, then we get picture of the graph. The surface is steep where the level curves are close together. It is somewhat flatter where they are farther away. So you can see these are the level curves with the height indicated by k is equal to different values. In particular, if for k is equal to 20 level curve, if this is lifted up to the height k is equal to 20, and like this way all these curves are lifted, we can get a picture of the graph of the function. And where the level curves are not close together, they are further apart, the graph is flatter, and when the curves are nearer, the graph is steep. Example, a contour map for a function f is shown. Use it to estimate the value of f1, 3 and f4, 5. Solution. The point 1, 3 lies between the level curves with z value 70 and 80. Here you can see 1 is over here, 3 is here. So 1, 3 point lies between the level curves 70 and 80, and it is just near the level curve 70. So we estimate that f13 is 73. Similarly, we estimate that f45 is 56. Now let us take examples. Sketch the level curves of the function fxy is equal to 6 minus 3x minus 2y for the values k is equal to minus 6, 0, 6, 12. Solution. Note that the graph of f is a plane in 3D, because we can write this as a z is equal to 6 minus 3x minus 2y, which is nothing but a plane in 3D. The level curves are 6 minus 3k minus 2y is equal to k, or 3x plus 2y plus k minus 6 is equal to 0. This is a family of line with slope minus 3 by 2. Because if you write this in the form y is equal to mx plus c, taking to y this side and all other expression right hand side, you will find that its slope is minus 3 by 2. The four particular level curves with k is equal to minus 6, 0, 6 and 12 are 3x plus 2y minus 12 is equal to 0, 3x plus 2y minus 6 is equal to 0, 3x plus 2y is equal to 0, 3x plus 2y plus 6 is equal to 0, by giving the different values of k in the last equation. The level curves are equally spaced parallel lines. These are the lines, because the graph of f is a plane. In this case, the graph of the function f is a plane. That's why we are getting these parallel lines. For different questions, you will get different figures or different curves. Example: sketch some level curves of the function f(x,y) is equal to 4x square plus y square plus 1. The level curves are 4x square plus y square plus 1 is equal to k, or when you solve this, you can write this equation in the form x square divided by 1 by 4 k minus 1 plus y square divided by k minus 1 is equal to 1, which for k greater than 1 describes a family of ellipse with semi-axis 1 by 2 square root of k minus 1 and square root of k minus 1. This is the family of ellipse or level curves. Again, if these level curves are lifted to the height given here, so we'll get the graph of the function like this. Functions of 3 or more variables. A function of 3 variable f is a rule that assigns to each ordered pair order triple x, y, z in a domain D, which is subset of R3, a unique real number denoted by f, x, y, z. For example, the temperature T at a point on the surface of the earth depends on the longitude x and latitude y of the point and on the time t. So, we could write t is a function of x, y and t. For example, find the domain of f if f x, y, z is equal to logarithm of z minus y plus x, y sin z. The expression for f x, y, z is defined as long as z minus y is greater than 0. Why this is so? Because logarithm function is defined for the value which are greater than 0. X, y and sin z makes no problem because sin is defined for all value of r and x, y is also defined. So the domain of f is D is equal to all points x, y, z belongs to R3 for which z is greater than y. This is a half space consisting of all points that lie above the plane z is equal to y. Remark, it is very difficult to visualize a function f of 3 variables by its graph because that would lie in a 4-dimensional space. However, we can know about f by examining its level surfaces, which are the surfaces with equation f x, y, z is equal to k, where k is a constant. If the point x, y, z moves along a level surface, the value of x, y, z remains fixed. For example, find the level surfaces of the function f x, y, z is equal to x square plus y square is equal to z square. Solution. The level surfaces are x square plus y square plus z square is equal to k, where k is greater than or equal to 0. These form a family of concentric spheres with radius root k as in the following figure. Thus, as xyz varies over any sphere with center 0, the value of xyz remains fixed. Here you can see these spheres. In particular, the equation of this sphere is x square plus y square is equal to plus z square is equal to 9. Similarly, the equations of other spheres are also given over here. Remark, function of any variable, any number of variables can be considered. Definition, a function of n variables is a rule that assign a number z which is equal to f x1, x2, xn to an n tuple x1, x2, xn of real numbers. We denote by Rn the set of all such n tuples. Remark, if a company uses n different ingredients in making a food product, Ci is the cost per unit of the ith ingredient and Xi units of ith ingredient are used, then the total cost C of the ingredient is a function of n variables x1, x2, xn, which is given by C is equal to function of x1, x2, xn, which is by equation C1, x1 plus C2, x2 and so on plus Cn, xn. The function f is a real valued function whose domain is a subset of Rn. Sometimes we use vector notation to write such functions more compactly. If boldface x is equal to x1, x2, xn, this is a vector notation, we often write fx in place of f x1, x2, xn. With this notation, we can rewrite the function f x1, x2, xn, c1, C1 x1 plus C2 x2 Cn xn, which is given in last example as fx is equal to Cx, where C is a vector C1 C2 Cn and C dot x denotes the dot product of the vector C and x in vector space n Vn. In view of the one-to-one correspondence between points x1, x2, xn in Rn and their position vector x, which is given as a vector x1, x2, xn in Vn, we have three ways of looking at a function f defined on a subset of Rn. First, as a function of n real variables x1, x2 up to xn. Second, as a function of single point variable, the point is given by with coordinates x1, x2 and so on, xn. Third, as a function of single vector variable x, which is having the components x1, x2, x3 and xn and so on in xn. This is the reference book textbook Multivariable Calculus 7th edition by James Stewart. This is used to prepare this PPT. Thank you very much.